Architecture is the art or practice of designing and constructing buildings. In order for a building to be visually appealing, safe, and well constructed, a range of different types of mathematics are used, these being geometry, algebra, ratios, symmetry, trigonometry, probability, and statistics. All of these types of mathematics work in unison and link in with geometry, allowing an architect to design and build a successful structure. Architecture is used in the real world in creating and designing infrastructure, housing, buildings, landmarks, bridges, and road signs. For hundreds of years, builders have based their designs on natural forms, for example, circles, and then used mathematical principles to make their design a reality. In 20 BC, Marcus Vitruvius wrote De Architectura, writing the proportions for how structures should be constructed, and stated that builders should use precise ratios when constructing. Vitruvius based the symmetry and proportion on the human body, this ratio being the golden ratio, 1 to 1.618. This ratio has been seen as the building block of all life and the hidden code in architecture, showing geometry's importance in architecture. Geometry in architecture is also used in determining which shape is strongest in building and using certain angles in order to construct a building. In one of Vitruvius's writings, he says that, in perfect buildings, the different members must be in exact symmetrical relations to the whole generic scheme. Buildings that are symmetrical are highly visually appealing. For example, the Great Pyramid of Giza in Egypt and the Taj Mahal in India. Both of these structures are highly symmetrical, making them visually appealing. Symmetry links with geometry through the use of shapes, for example circles and rectangles, as well as through the use of reflections and rotations in architecture. Ratios are used in architecture in more of a real-life scenario. For example, determining how much cement you need per 100 bricks. As mentioned earlier, the golden ratio, created by Vitruvius, is seen as a visually perfect ratio, this being 1 to 1.618. Human beings are pleased when things are in this proportion. Fibonacci also discovered that plants, animals, and humans are all based around this ratio, thus being called the golden ratio. This ratio has been used throughout time. For example, in Paul Carter's book Squaring the Circle, Carter examines that the ratio of the slant height halved by the pyramid's base is the same as the golden ratio for the Great Pyramid of Giza. Algebra is used in architecture to calculate weights and dimensions of buildings to make them safe in construction. If a building is too heavy, it will not be sturdy enough to support itself, as with if the dimensions of a building are not correct. It is also used in scale drawings and diagrams, used for planning out how a building will look. An example of a problem-solving technique using algebra and geometry could be if an architect was graphing the cost of materials for a building, they could calculate the cost and how much of a material they need through using a linear function. Algebra is used in geometry through finding out the area of a shape, or for an architect, the area of a room. Linked into algebra trigonometry, which can be used in architecture to measure angles, build arches or domes, and through the use of Pythagoras, find the height of a wall. It can also be used to calculate proportions in a room, for example, the length of a bedroom. Probability is used in architecture to help analyze data. For example, if an architect wants to build a house, they will have to look into the geographical probability, such as if the ground is stable enough to build on, as well as look into the geological probability, such as is the property close to goods such as shopping centres, close to transport such as train stations, or if the property is close to a busy road. All of this information is highly important to an architect, as these probabilities can either inflate or deflate a property's price. Architects also need to look into structural specifications, such as what materials are needed and how many workers are required. Probability is linked to geometry through geometric probability, this being a tool that helps calculate the infinite number of outcomes through measuring the geometric outcomes, for example length, area, and volume. Statistics are used in architecture in order to estimate the cost of labour and materials. Statistics are used to help budget an architect's project. They are also used, simply, to determine which material is the best to use in relation to cost, efficiency, safety, and the most reliable. An architect can also use statistics in the form of a survey, where they can determine the best characteristics for what they are building. For example, how many rooms, colours, price/rent, services, and location. All of these help an architect budget their project, while also help aid in their design and structural features. An example of statistics used to build comes from Sweden, where an architect firm used statistics from Hemnet to create the ideal home, using the country's most sought-after home in relation to price, the number of rooms, living space, and the number of floors, resulting in a property with one double and single bedroom, an open kitchen/living room, one bathroom, and a balcony, with a cost of €300,000. This real-life example shows how statistics can be used to aid in architects' design. Geometry in architecture has been used for hundreds of years, and is clearly shown through the work of Leonardo da Vinci, who followed Vitruvius' idea that the human body was linked to architectural design, with these ideas forming the basis of Renaissance proportion theories in art and architecture. Da Vinci's Vitruvian Man perfectly examines how geometry is used in architecture, and how the human body and the golden ratio are the backbone to architecture. The Vitruvian Man shows the figure drawn within both a square and a circle, showing Vitruvius's point that a temple should relate to the parts of both a circle and a square. The man is likened to a building shown through the proportional lines, and is seen as a reflection of human proportion and architecture, further outlining how the human body is similar to the proportion of a building, and shows how the golden ratio of 1 to 1.618 is the backbone of modern architecture. On top of architecture using a range of mathematics, it also covers other aspects of STEM: science, technology, engineering, and maths. Science in architecture includes building to withstand natural disasters, for example earthquakes and hurricanes, soundproofing rooms, or making houses and apartments fire safe. Architects also have to make sure that their infrastructures are sustainable for the future, as well as environmentally and economically sustainable. Through the improvements in science, architects have been able to make infrastructure tick these boxes more and more, making them safer, cheaper, and less harmful on the environment. Improvements in technology have also resulted in improvements in infrastructures. Although some architects continue to use traditional tools such as slide rulers, compasses, and pencils, there are a range of new technologies, including CAD, which is Computer-Aided Design, a software that has replaced the drafting board. It also allows architects to analyze structural strength and weaknesses, allowing an architect to see if their design will work. Another example is building information modeling, allowing architects to draw and design building plans for analysis. Both of these new technologies allow for an architect to test and examine if their infrastructure is well designed. There are both positive and negative environmental impacts in architecture. For example, according to the USGBC, buildings account for an average of 41% of the world's energy use, due to the amount of electricity involved in buildings, such as lighting. While building, there is often a lot of wasted materials left over, which gets thrown into landfill or incinerated, polluting the air. From USGBC, around 40% of the world's raw material are used while constructing a building. There is also a lot of pollution in transportation. Architects have also built properties to blend in with the landscape/environment around it. For example, the T-Pavilion Posbank in the Netherlands, designed by Mastenbroek, has a grass roof, the insulation is made out of sheep's wool, the toilets are flushed with rainwater, and the design of the beams and bars blend in with the environment around it. Properties like this help not deface beautiful landscapes and views, and help the house blend in, making it seem like it should be there instead of an ugly, non-thought-out high-rise. Architects' impact on modern life is enormous. Architects design infrastructure such as houses, roads, and apartments, and is invaluable to modern life. Beginning with Vitruvius with his golden ratio of 1 to 1.618, to Leonardo da Vinci, and to modern time, where architects are still using similar techniques with improved technology. Architecture involves a range of different types of mathematics as well as STEM.